Welcome to the video tutorials of Mechanisms by Mechanismalar. This video and its contents are being prepared as a collaboration between Mechanismalar.com and Alteros. In this video, we will focus on the inner workings of Alteros's air pressure boosters. We want to thank Alteros for their technical contributions and generous support for making this animation possible. Pressure boosters are important components in many applications where high pressure is required, such as high-pressure hydraulic presses, CNC water cut machines, and intense air pressure requirements of certain applications. Alteros Company offers their pressure boosters especially for air gun shooters, paintball players, and scuba divers to fill their high-pressure air tanks at home. Before going into detail on how this air pressure booster works, we want to first highlight its major components so that your understanding of the inner workings of this system becomes easier. At first, the inner workings of the air pressure booster may seem very complex, intimidating, and hard to understand. However, this is not the case. What makes this device so elegant is its simplicity and the high-quality workmanship used in its production. It uses two main circuits called the reciprocation circuit and the pressure boosting circuit. A third circuit, which is an extension of the reciprocation circuit, is called the cooling circuit. Now, let's describe the details of each of these circuits. The reciprocation circuit. The compressed air coming from the workshop compressor is connected to the P port of the control valve, and it is called an inlet pressure. This compressed air is diverted to A and B ports of the large pneumatic cylinder, which can handle pressures between 5 to 10 bar or 75 to 145 psi. The control unit sends the appropriate signals to the solenoid of the flow valve, which controls the direction of the inlet pressure to A or B ports of the air cylinder. If the inlet pressure is diverted to the A port of the large cylinder, the air in the B port must be exhausted to the atmosphere at point R, which stands for right. On the other hand, if the inlet pressure is diverted to the B port of the large cylinder by the flow control valve, the air in port A must be exhausted to the atmosphere at point L, which stands for left. It is being said that the air should be exhausted to the atmosphere at points R and L, but they are not exhausted to the atmosphere there. We will explain the reasons behind it later in this presentation. The pressure of the air at point L and R are between 1 and 2 bar or 15 to 30 psi. The pressure boosting circuit. The pressure boosting circuit starts its journey at point C. Point C is the point where the shop air is split into two paths. The first continuous flow path is connected to the P port of the control valve to feed the reciprocation motion. The second intermittent flow path is connected to the medium pressure cylinder through the check valve at point D. During the leftward motion of the large pistons, the air coming from point D is sucked into the medium pressure cylinder by the medium pressure piston. During the rightward motion of the medium pressure piston, the check valve at point D is closed and the air inside the medium pressure cylinder begins to increase. When the pressure reaches 20 to 60 bar or 350 to 800 psi, the check valve at point E opens and the medium pressurized air begins to flow toward point F. At that time, the high pressure piston is also traveling rightward, and this causes the check valve at point F to open and the air to flow into the high pressure cylinder. This process continues as long as the large cylinder makes the rightward journey. Once this journey is completed and the leftward motion starts, the check valve at point F closes. This causes the pressure inside the high pressure cylinder to begin to increase. When the high pressure reaches 100 to 300 bar or 1,500 to 4,500 psi, the check valve at point G opens and the pressurized air reaches its final destination in the high pressure tank. Now the question is, why is the exhaust air not expelled from the large cylinder at points L and R? To answer this question, we need to first explain that when gas is compressed, their temperature increases, and when gas is cooled, their pressure is reduced. Everyone who has fixed a flat tire on a bike knows that when the air is pumped into the tire by a handheld compressor, it gets hot. Since medium pressure and high pressure cylinders are always compressing the air, the temperature of the cylinder walls will get hot. This will increase the temperature of the air coming to the medium and high cylinder chambers. When the air temperature rises before the compression, rather than wasting this cool air by expelling the air into the atmosphere at points L and R, it can be used to cool medium and high pressure cylinders. The air coming from point R is directed to R1 with the plastic tubing. This is because plastic has a poor heat transfer rate and we want to keep the air cool. From point R1 to R2, the exhaust air travels between the medium pressure cylinder and the pipe jacket surrounding the medium pressure cylinder. I assume this jacket also has low heat transfer rate since we don't want to cool it. The air moves between the medium pressure and the jacket in a spiral motion to increase cooling efficiency. While the medium cylinder cools, the air gets hot and expelled from point R2 to the atmosphere. The same can be said for points L, L1, and L2 for the high pressure cylinder. The inner workings of the control unit is beyond the scope of this presentation. However, it is important to know that the control units detect the location of the large cylinder from left switch LS and right switch RS when the large cylinder has contact with them. You can observe this event when the connecting wires glow. When the control unit receives the signal, it sends the appropriate signal to the solenoid of the control valve. I hope this explanation helps you better understand the inner workings of the ingenious pressure booster. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to our channel and hit the like button. We appreciate your support.